Hello guys, welcome to day 6 of 100 days DSA challenge. As part of day 6, we are going to solve LeetCode problem. Remove duplicates from sorted array.
So every problem has two approaches. One is brute force approach and the second one is optimized approach. So we are going to solve this problem by using these two approaches. So now let us first understand the problem descriptions what they have given. They are telling that they have given an integer array called as nums. So which is sorted in non-decreasing order. So integer array means the array contents of the integer elements, right? So that is called as an integer array and it is sorted in the non-decreasing order. So whenever we are reading a problem descriptions while solving the LeetCode problems, we must be aware of some key terms which are specified in the problem description. Suppose in this case they are telling that the array is sorted in the non-decreasing order. So what is meant by the non-decreasing order? Non-decreasing order is the key term here. So the current element is greater than or equal to the previous element. That is called as a non-decreasing order. Is this clear for you? So we have to remove the duplicates in place such that each element should appear only once. So that's what we have to do, and at the last we have to return the number of unique elements which are present in the given array. Okay, now so now let us see sample test cases. Let us see here. So this is one input array. So in this input array there are three elements, right? So and in this one is repeated two times. I mean one is duplicated one time. Okay, and the two is unique element which is appeared only once. So what we have to do here, we have to remove the another duplicate of one here. After removing the another duplicate of one, what is the output of this array? So the output should look like this, isn't it? Okay, now so we have to remove the duplicate elements and we should not have to focus on the remaining empty spaces of the array, and we have to return the number of unique elements after removing the duplicates. So in this case, how many unique elements are there after removing the unique elements? 2, right? So we have to return 2. So this is the output in our case. And coming to this case, so this is the array which contains almost every element is duplicated except 4, right? So 0 is repeated one time, 1 is repeated 3 times, and 2 repeated twice, and 3 repeated twice, like that. So what we have to do, so after removing the duplicates, the array will look like this: 0, 1, 2, 3, 4. So how many unique elements are there? 1, 2, 3, 4, 5. So we have to return output as 5. Is this clear, all of you? Yeah, so that's what we have to do. I hope that you guys are clear with the input arrays, right? So now what will you do? Just pause the video for at least 20 minutes to half an hour and try to solve this problem by using the brute force approach. Okay, na? So then you will able to find out the more number of ways to solve a problem. Then your logical thinking will be improved a lot. Okay, na? So please stop the video and try at least 20 to 30 minutes. So coming back to the video, let us solve this problem by using the brute force approach. See, they are telling that the array is the sorted array, right? So which is sorted in non-decreasing order. So non-decreasing order means current element should be greater than or equal to the previous element. So this is what is meant by the non-decreasing order. So now what we will do, the best case in sorted arrays is all the similar elements will come to the side by side, right? If you see this example, 2 and 2 both are the same elements, right? So they came corresponding to each other. Same elements will be placed to the side of each one. So here 2 and 2 are the same elements which are placed one after the other, and here 4 also in the similar way. So what I will do, so simply I will take one more extra array, then I will place the only unique elements in this array. Okay, now I think this is clear for you. And if the element repeated twice, then I am not going to place the duplicated element in this array. Let us consider sorting element as the unique element. So I am placing 2 here. And now coming to the second element. So the second element we have to compare with the previous element, right? It is equal to the previous element. So we should not add this element to the new array. So I am ignoring this element and coming to this element. Now 3. So 3 and 2 both are not equal, right? So I am placing 3 here. Okay. Now 4. So 4 and 3 are not equal, right? So I am placing 4. Now compare these 4 with the previous 4. So the current 4 is equal to the previous 4, right? Yes, it is equal. So we should not place 4 again. So now coming to this element. So compare 5 with the previous element. So previous element is 4 and the current element is, both of these elements are not equal to each other. So we have to place 5 here. And the remaining 2 empty space will be filled with a blank or leave as empty. Don't bother about these remaining empty elements. Is it clear? So now what I have to do after this? Again I have to place these elements back into this array. That's what we can do. Simple, na? So this is the very easiest approach for solving this problem. Yeah, so I will provide the code for this brute force approach in the description box, so you guys can check out there. Okay, na? So for timing, I am not going to write the code for this. Let us find the time and space complexity for this problem. If you see here, we require order of n time complexity, right? Because we have to compare each element with the previous element, right? So if n elements are present in a given array, so the total amount of time required for solving this problem is order of n, isn't it? Yeah. So what is the space complexity in this case? So we are using extra space for solving this problem. We are taking an extra array for solving this problem, right? We are using order of n extra space for solving this problem. Let us solve this problem by using the optimizer approach, where we are not going to use any extra array for storing the unique elements. Okay, let us see how we are going to solve this problem by using the optimizer approach. So we are going to use the 2 pointers technique in the optimized approach. So 2 pointers technique means we are going to use the 2 pointers. One pointer is going to be incremented when the unique element is placed, and the another element gets incremented iteratively. Okay, so now what we will do here, so in each iteration what we are going to do, we are going to compare the current element with the previous element. If both of them are not equal, then we are modifying the array. Okay, so if both of them are equal, then we are simply ignoring that value, right? So how we are going to do this? In each iteration what we are going to do, so we are going to compare the jth value with the previous ith value. Here I am using the 2 pointers, I and j. I is used to represent the number of unique elements or the last unique element, and the j is used to represent the current element. Okay, now so I is used for to represent the current number of unique elements, j is used to represent the current element. Okay, so I am taking a loop. I will start from this and I will traverse until here. So I value will be start from at 0, and j is placed at, j is starting at the I plus 1 location. Okay, so now I value is 0 and j value is 1. This is fine. Now what we will do, in each iteration we will compare jth value with the previous unique element, isn't it? So if the current element is equal to the previous unique element, then their duplicate element is found. So we have to remove that. We have to ignore that element, right? Then only we can remove the element. If we ignore the element, that is equal to the removing the elements. Simple, right? So now what is the condition we are going to check? So this is the condition which we are going to use in this case. Is it clear? Let us see whether the value which is present at nums of j and the value which is present at nums of I, whether they are equal or not. So if both of them are equal, right? So in this case, 2 is getting equal to 2, right? So we won't get into this if condition. So the I value remains 0 and the j value gets incremented. So now the I value is 0 and the j value will be 2. So after this what we will do, now let us increment the j value. So j value gets incremented to, right? So j value gets shifted to here. Now let us compare 3 with the previous unique element. So previous unique element is what? 2. So now the current element is 3. Now compare 3 with 2. So both of them are not equal, right? So now what we will do? So we will place these 3 at this place. We compare 2 elements, right? So after comparing 2 elements, we can able to find that element is duplicated or unique element. If the unique element is found, then what we have to do? We have to place that current unique element at the index next to the previous unique element. Is it clear? Isn't it? So this is the previous unique element. So this is the current unique element. So where we have to place this current unique element? At the next index to the previous unique element, right? For that we have to increment the value of I first before placing the current unique element. So the I value gets incremented. So I am incrementing the 1 I value. So I value is now 1, right? So now this value, the current unique element is placed at this place. Simple. Now j value gets incremented. So now the j value will become 3. Yeah. So now compare the value which is present at j and I. So at the j we have 4. Yeah. So we have to compare 4 with 3. So both of these are not equal. Again we have to increment the I value. I value will become 2 and the j value will be, the current unique element will be placed here. The current unique element will be 4. Now the j value also goes to next iteration, that is 4. So the current element is 4. So now compare this element with the previous unique element. Previous unique element is 4 and the current element is 4. Both of them are equal. So we are not going to enter into this if condition. So the I value remains 2 again and the j value gets incremented in the next iteration. So this is the current element. So the current element is 5 and the previous unique element is 4. Let us compare these two. So 5 and 4 are not equal to each other. So I am going to increment the value of I, right? So and then after that I am placing 5 in ith location, the index of the previous unique element. So this is how we are going to remove the duplicates from the sorted array. So after this, what we are going to do, we have to return the number of unique elements which are present here. So here the I value is after finding all the elements, what is the I value? It is 3. But we have found, right, because we are starting the I from the 0. So that's the case, we are not getting the I value as equal to the count. The count will be plus 1 to the I value. So we have to return I plus 1. So that's how we can find the solution for this problem by using the both brute force and the optimized solution. So if you are new to our channel and if you also wanted to learn DSA along with me, just hit that like button and consider subscribing to our channel. So that makes me motivated and helps in making the videos consistently without any interruptions. So let's learn together and grow together.